Alright, we're going to be looking at ions here. Ions. So far we've been looking at atoms that have no charge. Now we're going to start talking about charge. So an ion is going to be a charged atom. And what that means is that if there are more protons than there are electrons, that means you have a positive ion. And a positive ion has a special name. It's called a cation. Now you can also have the opposite situation occur. What if the number of protons are less than the number of electrons? That's giving you a negative ion. And that has a special name too. It's called an anion. Now, let's look at some symbolism for that. Sometimes you'll see this sort of thing. We actually talked about this earlier, where we have the atomic number, which tells us the number of protons. And we have here, let me just get this out of the way, the mass number, which is protons plus neutrons. Well, now we're going to be throwing another thing on here, and it's going to be the charge. So let's look at this very simple hydrogen atom. This hydrogen atom has an atomic number of 1, which means it has 1 proton. There it is. Because it has 1 proton, if it's electrically neutral, that means there's going to be 1 electron, and that's how I'll represent that. So we have our proton here, and that's in the nucleus, and we have our electron up here, and that is up floating around the nucleus. Now this is not to scale. I repeat, not to scale. And I'm just going to do a little of this and draw a little arrow. So any hydrogen atom, and one way we can describe this is kind of the electron orbits the nucleus. I've told you a number of times that this is not the modern model of the atom, but it's something we can work with. So here we have 1 proton, 1 electron. Now, that's going to have no charge because the number of protons equals the number of electrons, and they're going to negate each other, sort of. So what's going to happen here, in certain circumstances, hydrogen can actually get rid of its electron. It can actually be taken from the hydrogen. So I'm going to erase it. If you take the electron away from hydrogen, then you find that it has 1 proton and 0 electrons. That's going to give it a charge of +1. And the way we write it is we put it up and to the right. Now, I'm going to write +1. What you're going to find is that we don't actually write the number 1 when we have charges. So I'm just going to erase it. The plus alone means +1. So now we have this other little bit of nomenclature which tells us how many, it tells us the charge, and we can sort of figure out how many electrons a substance is going to have. Let me give you another example. Let's slide us up. The example that I'll use this time is going to be, let's see, I'll go with magnesium, Mg. Magnesium has the atomic number 12, and we'll say this is magnesium 24, which means it's kind of this, stable in terms of the nucleus. So here, this tells us that we have 12 protons. What if this magnesium, instead of having its 12 electrons, like it would if it was neutral, if it had 14 electrons? What would that mean? Well, what you see here is a difference of 2. So there's 2 more electrons than there are protons. All that means is that it's going to have a charge that is what we write 2 negative. The difference is 2. The difference is 2, and the charge is negative because there's more electrons than there are protons. We can make a little formula for this. Protons minus electrons equals charge. And squeeze it in. Try it out. We have the 12 protons minus the 14 electrons, and that equals minus 2. You'll notice that I wrote 2 minus up here. For some reason, that's how you see it written. You can write negative 2 or 2 minus. I don't particularly care, but 2 negative. And that's about it. Ions.